Welcome to Solving Equations with Radicals. To solve an equation that contains a radical, there are three simple steps you need to follow. The first one is to isolate the radical. This means to get it alone on one side. In our example problem, this is easy. All we need to do is add 2 to both sides. So we get the square root of x, which is the radical all by itself on one side, equals 5. Step 2 is to square both sides. That means you put the entire side in parentheses and square it. The square root of x squared is x, since the square root symbol and the squared cancel each other out, and that's equal to 5 squared, which is 25. Our last step is to solve, but since x is equal to 25 and we have x alone by itself on one side, this equation is already solved for us. Let's practice what we just learned. If you're feeling comfortable, pause the video now, try these problems on your own, and then check them with my solutions. If you're not feeling comfortable yet, watch me do the first one and then try the second problem on your own. So for the first example problem, we're going to add 8 to both sides because we're solving for the square root symbol. So we get 4 times the square root of x equals 8. Now, to get the square root of x by itself, we divide both sides by 4. The 4 on the left side of the equation is canceled out, and you get the square root of x is equal to 8 divided by 4, which is 2. Now, our step 2 is to square both sides, and this gives us just x on the left side and 4 on the right. And there's no more solving that needs to happen here, so x equals 4 is your final answer. Now pause the video and try example problem number 2 on your own. Alright, let's check to see what you got. First step is to get the radical symbol and the square root stuff all on one side. So we're going to add 5 to both sides. So we get the square root of 7 plus x is equal to 5 plus 1, which is 6. Now, even though our square root symbol has more than just x in it, 7 plus x, we can still square both sides to get rid of that square root symbol. To get 7 plus x, since the square root symbol and the squared cancel each other out, equals 36. We subtract 7 from both sides, so now we're solving for x, and x is equal to 29. Let's look at a couple special cases. Our first case, we have two radicals. For a problem like this, you want to put one radical on both sides. So you're going to get the square root of 2x plus 4, so that's the first radical, and you're going to add the square root of x plus 8 to both sides. So we get square root of x plus 8 on the right side. Now, just like the other equations, now we have one square root on both sides, and if we know that if we square either side or both sides, that we'll get rid of those square root symbols. So we always have to do the same thing to both sides, so we'll square them both. And we get just 2x plus 4 on the left is equal to x plus 8 on the right. Now we solve, moving our variables to the same side, so subtract x from both sides, that gives us x plus 4 is equal to 8. And now we get x alone by itself to solve for the final answer, and we subtract 4 from both sides to get x equals 4. Our second problem is special because we get two solutions. You're going to have to remember some of your factoring unit for this one. So we already have the square root alone on one side. That means step 1 is done for us, and we need to go to step 2, which is squaring both sides. The square root of 12 minus x squared is going to get rid of that square root symbol, so we get 12 minus x is equal to x squared. So this might look a little bit like those trinomials we were doing for a while. So let's put everything on one side just like we would for a trinomial. And to do that, we want to go ahead and keep our x squared term positive because it makes it a little bit easier. So let's add x to both sides, and we get 12 equals x squared plus x. And let's move our 12 to the other side also. And so subtracting 12, we get 0 equals x squared plus x minus 12. We've learned a couple different ways to deal with this, and one of them is to use the quadratic formula, but for this type of problem it's even easier to factor. So let's keep the 0 on the left, put our two sets of parentheses, and we need to figure out what two numbers multiply together to equal negative 12 and add together to equal positive 1. And those two numbers are going to be positive 4 and negative 3. So 4 minus 3 would give you that positive 1 that goes right here, and 4 times negative 3 would give you that negative 12 over here. Now we said both individual parts equal to 0 because it doesn't matter which one is 0. Anything, the first quantity multiplied by the second quantity if it's 0 will be 0. And if the first quantity is 0, it doesn't matter what the second quantity is, it's still, the whole thing will still be 0 because anything multiplied by 0 is 0. So we get x plus 4 equals 0, and we get x minus 3 equals 0. For the first equation, we're going to subtract 4 from both sides, so we get x equals minus 4. And for the one on the bottom, we're going to add 3 to both sides, so we get x equals positive 3. And both of these are your solutions. Let's look at another couple of special cases where the problems have no solutions at all, or at least no real solutions, and we'll talk about what that means in a minute. So just like our other problems, we're going to go ahead and say the square root of 3x equals negative 9, because we're going to subtract 9 from both sides. So square root of 3x equals negative 9. So I know back when you were doing square roots a long time ago, you would know the square root of 64 equals 8, the square root of 4 equals 2. But what happens if you have the square root of negative 4? This is called a non-real solution. So your answer here is going to be no real solutions. In later math classes, you're going to learn about imaginary numbers, where your answer is 2i, where I stands for imaginary, but we're not going to worry about those in this class. So as soon as you see that the square root is equal to a negative number, go ahead and write no real solutions. So remember, there are solutions, but not ones you need to worry about in this class, so we're going to say no real solutions. Let's try our second equation over here on the right. So we want to go ahead and put our second square root on the other side so that we can square both sides. So we get the square root of x plus 1 equals, remember we're going to add the square root of 7 plus x and add the square root of 7 plus x to both sides. So we get square root of x plus 1 equals the square root of 7 plus x. Square both sides, like we learned in the last page of this slide, and we get x plus 1 equals 7 plus x. Now we subtract x from both sides, which is going to give us no x's on either side, and we get 1 equals 7. And just like any algebra equation where we get two numbers that are clearly not equal to each other, so this is not a true statement, they are not equal to each other, we know that there is no solution. So now you know how to deal with problems, regular radical problems where you use the three-step method. You know how to solve problems with two solutions where you have an x that's inside the square root sign and outside of the square root sign. You know how to solve equations with two radicals that are similar to this one right here, where you put one square root on each side, and you know how to recognize problems that are going to have no solutions. So good luck with these problems on your own, and I hope you enjoyed the video.